Solving problems by inductive reasoning. Objective: distinguish between inductive and deductive reasoning. Let's first cover some definitions. Definition: conjecture. An educated guess based on repeated observations of a particular process or pattern. Inductive reasoning. Characterized by drawing a general conclusion, which involves making a conjecture, from repeated observations of specific examples. The conjecture may or may not be true. Deductive reasoning, characterized by applying general principles to specific examples. So again, the big difference between inductive reasoning and deductive reasoning is that with inductive reasoning, your reasoning goes from specific examples to a general statement. However, with deductive reasoning, you're using general facts to come up with or to reason to or to deduce a specific outcome. Definition: exponential expression. If a is a number and n is a counting number is one that we count with, so they start at 1, go to 2, 3, and then on forever, then the exponential expression a to the n power is defined as follows. A to the n is equal to a times itself n times, and each of these guys here we call a factor, so n factors of a. The number a is the base and n is the exponent. A couple more definitions. Definition of a premise can be an assumption, law, rule, or widely held idea or observation. A conclusion: reasoning inductively or deductively from the premise. Could have more than one premise as well. You could draw a conclusion from one or more premises. Logical argument, made up of premises and conclusions. It's time for an example. Here's our first example: identifying premises and conclusions. Identify each premise and the conclusion in each of the following arguments. Then tell whether each argument is an example of inductive or deductive reasoning. Let's look at part A. Our house is made of brick. Both of my next door neighbors have brick houses. Therefore, all houses in our neighborhood are made of brick. Let's first identify the premises with this problem. There are two premises. The first premise is our house is made of brick. The next premise is both of my next door neighbors have brick houses. The conclusion is, therefore, all houses in our neighborhood are made of brick. Notice that with this problem, our reasoning goes from specific examples. The first specific example was that our house is made of brick. The next specific example is both of my next door neighbors have brick houses. And then we're generalizing. We're saying, therefore, all houses in our neighborhood are made of brick. So again, we're going from specific to general. So this is an example of inductive reasoning. And our conclusion, the fact that all houses in our neighborhood are made of brick, may be true or it may not be true. Let's look at letter B. All keyboards have the symbol @ I have a keyboard. Therefore, my keyboard has the symbol @. Let's identify the premises with this problem. The first premise is all keyboards have the symbol @. The second premise is I have a keyboard. The conclusion is my keyboard has the symbol @. This is an example of deductive reasoning because we're going from general to specific. All keyboards have the symbol @. That premise is a general statement about everything, about all. And then the next premise, again, we're getting more specific. I have a keyboard. And then our conclusion is very specific. Therefore, my keyboard has the symbol @. So again, this is an example of deductive reasoning. C. Today is Tuesday. Tomorrow will be Wednesday. Let's identify the premise. This problem has only one premise. The premise is today is Tuesday. The conclusion is tomorrow will be Wednesday. This is an example of, again, deductive reasoning. The fact that Wednesday immediately follows Tuesday is being used, even though this fact is not explicitly stated. So because the conclusion comes from general facts that apply to this special case, this is an example of deductive reasoning. Let's look at another example involving inductive reasoning. Predicting the next number in a sequence. Use inductive reasoning to determine the probable next number in each list below. So our job with these three problems is to try to determine some type of pattern that we think is what's going on, and then using that pattern come up with what we think the next number probably would be. For instance, with letter A, we have 5, 9, 13, 17, 21, 25, and 29. Let's try to come up with a pattern that relates one number with the next. So how can we get from 5 to 9? Well, we can add 4. Notice that if we keep adding 4, we get the next number. 21 plus 4, 25 plus 4 is 29. Therefore, if we keep this pattern of adding 4, then we would guess that 33 is the next probable number of that sequence. Letter B, 1, 1, 2, 3, 5, 8, 13, 21. Well, if I take the first two numbers, add them together, I get the next number. Then if I take the previous two numbers, 1 and 2, add them together, I get the next number. 2 and 3 give me 5. 3 and 5 give me 8. 5 and 8 give me 13. 8 and 13 give me 21. Therefore, we'll take 13 plus 21 and get 34 as the next probable number. Letter C. Let's find a pattern. Looks like if we double a number, we get the next term. Double 2, or 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2, 64 is our next probable number. Again, this is inductive reasoning. The next term may or may not be what we have written here, but the pattern is telling us inductively that those are probably the next numbers of the sequence. Next objective. Understand inductive reasoning may not lead to valid conclusions. Let's take a look at a couple of definitions quickly in terms of definitions of a circle. Again, we all can understand the general shape of a circle. However, the definition in mind is if we start placing points on the circle and start connecting those points using a segment. For instance, with my second circle, letter B, if we connect these 2 points with a segment, that segment is called a chord. So using inductive reasoning, I want you to notice that if I place, look at letter A, if I place one point on the circle, I ask how many chords can be drawn. Well, that answer is 0 because I need another point to draw a chord. I want you to ask yourself, how many regions has the interior of the circle been divided up into? So therefore, with one point placed on the circle, we still have the entire interior of the circle, not divided up into any subregions. So there is only one region. So look at the chart. When we have one point on the circle, we still have one region of the interior of the circle. Now let's go to letter B. Let's place 2 points on the circle. Now we can draw in this chord. And now you can see that we're starting to subdivide the interior of the circle into subdivisions. So with 2 points placed on the circle, we can draw one chord. However, I want you to count the number of regions. We now have 2 regions. Let's repeat this process. Letter C, we now have 3 points. allowing us to draw 3 chords, but now we count up the number of subregions and we end up with 4. We repeat the process with 4 points, we get 8, and finally with the letter E, 5 points gives us 16 regions. So now I ask, using inductive reasoning, if I place a 6th point using inductive reasoning, how many regions would we guess? So let's look for a pattern. Looks here that we multiply by 2, multiply by 2, multiply by 2, multiply by 2. So our guess is that with 6 points, we should end up with, after I double 16, multiply 16 by 2, we would guess 32 regions. And that is incorrect. Look at the picture I have over here in the bottom left. When you add a 6th point and count and draw all possible chords, count up all possible distinct subregions, you actually end up with 31. So here's a case where inductive reasoning may lead you astray. Let's try an example. Use inductive reasoning to make a prediction. Instead of counting interior regions of the circle, count the chords formed. Use inductive reasoning to predict the number of chords that would be formed if 7 points were used. So let's start with a circle, and again we're going to start adding points to the circle and drawing all possible chords, and we'll count up the number of chords. So what would happen if I have 1 point? 1 point. How many chords can be drawn? Well, I need 2 endpoints, so 0 chords can be drawn. Now let's introduce a second point. So let's say we have 2 points. Add a point to the circle. How many chords can be drawn? We can draw 1 chord. Let's add another point. 3 points. How many possible chords are there? Well, we have the one that we have now, plus this chord, plus this chord, for a total of 3 chords. How about 4 points? Adding a point. We have the 3 that we currently have. How many additional can I add? I can add 1, 2, 3 more, giving me a total of 6. Let's introduce a 5th point. So I currently have 6 chords. How many more can I draw in? So I can add 1 more there, 2, 3. I can add 4 more chords. So a 5th point allows us to have 10 chords. Is there a pattern? Can we come up with a prediction? We're being asked if we add 7 points, how many chords do we have? So let's find a pattern. Here we're adding 1, here we're adding 2, here we're adding 3, here we're adding 4. So for 6 points we would add 5, and for 7 points we would add 6. 6 plus 15, 21. So using inductive reasoning, our guess or our conjecture is that there will be 21 chords.